We're going to talk about another thing that you can do with integrals. We've been talking about differential equations and ways that you can use those. We're also going to be talking about area. Now, the first problem here, we've already done this problem before. I just want to remind you how to do it. The first thing you would do is you would graph this thing in the calculator. And it looks kind of like that. It says to shade the region bounded by that in the x-axis. What that means is that this and this are the two sides of the figure that you're looking at. So I'm trying to find this area right here. What we have figured out is that if I find this value and this value, that I need to do the integral of those two values and then of the equation. You can put this in the calculator. Remember, you can go to the calculator screen, excuse me, where the y values are, and at y equals, and then go to second calc and find the area, or you can go to Math 9. You do need to find the two zeros. I will just go ahead and tell you that it is 0.732 and 2.732, and you can do that on the calculator just to make sure. And then if you put this in the calculator, you should get 6.928. Make sure that the rounding is correct. In the calculator, you do have to use the whole decimals. You can't just round them off. So number one's kind of, we've already done those kind of problems before. And number two, kind of, we did too. I just wanted to talk about it because it looks different with all the information that it gives you. So it says to shade the region bounded by x equals 1, which is a vertical line, x equals 2, another vertical line, the x-axis, and then this other curve. Alright, if I graph this curve, it kind of looks like that. Okay, and so the part that I'm looking for where all those things intersect, so I'm looking for this area here. Basically, that would mean that I need to find the integral from 1 to 2, again of the same curve. Put that in the calculator, you get 2.666. If you don't like that number, change it to a fraction and you get 8/3. Still nothing very new, just kind of thinking about these pictures and how you would draw them and what would be different about them depending on the placement. Notice that all these things right here are the boundaries to the figure you're looking at. So it was that, and that. And so it's the part that's inside of that you're looking for. Alright, number 3, shade the region bounded by that figure and the x-axis. So first thing I'm going to do is I'm going to graph it. I'm going to move my x-axis a little bit above it because what happens is the graph looks kind of like this. It's below the x-axis. So this is the part that I'm looking for. Go ahead and find those zeros. That is negative 1.236 and 3.236. Remember what we know about areas and integrals. If I find the integral from negative 1.2 to 3.2, I'm going to get a negative number because the area that you're looking for is totally below the x-axis. So what I need to do is I need to change that negative to a positive because I'm actually looking for the area. I'm not looking for the integral, I'm looking for the area. So what I would do is I would have a negative on the outside, integral of x minus 1 squared minus 5 from negative 1.236 to 3.236. Make sure you use the whole decimal. Put that in the calculator, you get 14.907. Now, what you're going to find out is that we're going to have different figures, and no matter what the figure is, when you find the area, you're going to be looking at the top function and the bottom function, and you're going to subtract those two functions. So what I want you to know is that this is the same as saying 0 minus the function from the same values, because 0 is the top function, and then the parabola is the second function. So that would be another way to write that, but that's why there's a negative on the outside. Alright, number 4. It wants us to shade the figure, figure out what would be shaded, and find the area. All right. So if I graph negative x plus 2, well, I know it looks like that, where this is 2. And then it says graph x equals 1. So that would be x equals 1. So it wants me to use that, the x equals 1, the x-axis, and the y-axis. So it's actually asking me the area of that little trapezoid there. You still can just find the integral from 0 to 1 of the function. For now, you can put that in the calculator, you get 1.5. If you would prefer to just find the area of that trapezoid, you can, and you would get the correct answer. On 4A, B, and C, what I'm trying to get you to practice is just what part of the figure is going to be shaded, because that is also something that's kind of confusing. So on B, it says to shade, it says y equals x, x equals 1, and it says the x-axis. So y equals x equals 1, and the x-axis. So it's just asking for that little bitty triangle right there. If you just want to find the area of that triangle, that would be okay. But to write the integral, it would be from 0 to 1, because this is at x equals 1. That function there is y equals x, and then we're going to the x-axis, so it's from 0 to 1 of x, and I get a half. Alright, the C part. Alright, it wants me to take that negative x plus 2, it wants me to take y equals x and the y-axis. So it's asking me for this figure right here. Now, just briefly, I want to show you that in the A part, we found the area of that little trapezoid. In the B part, if I sort of graph it together, see the area of the trapezoid. In the B part, we found the area of this little triangle right here. Okay, I didn't do a very good job drawing it. I think I'm going to have to redraw it. Okay, in the A part, we found this purple area right here, this area of the trapezoid. In the B part, we found the area, that little yellow part, which is the area of the triangle. What I want you to realize is that if I take the A part, which is the trapezoid, and I take the B part, which is that little yellow triangle, and I subtract them, that I should end up with what I'm actually looking for in this problem. I should end up with just that inside part right there. And so one way to write the integral is to say the integral from negative x plus 2, 0 to 1, and subtract the integral from 0 to 1 of x. Because this is the A part and this is the B part. And you would get 1, because it's 1.5 minus 0.5. Now, another way that you can write that is the integral from 0 to 1 of negative x plus 2 minus x. What I want you to realize is that when we're finding an area between two curves, if it's not the x-axis, you can take the top function and you can take the bottom function and you can put them in an integral and subtract them, as long as your limits, are the same and everything. You can take the top minus the bottom and you'll get the same thing. And I'm showing you that it works in C, but if you can understand that it works, it makes it a little bit easier, because a lot of times you're going to be finding the area between two curves, and when I find those, it's easier if you can do top and bottom and subtract, rather than having to think about each part of it and how it works out that they subtract. Alright. Alright. On that 5A, it says draw a graph to represent what's found. It says find it algebraically. So first I'm going to draw this graph. 4 minus, and it says no calculator. So 4 minus x squared means a parabola that's turned upside down, up at 4. It says that it wants us to go from -2 to 1. If you plug in -2, you get 0, so that's -2. If you plug in 1, you get 3. So it's from right there. So this particular integral is asking us to find the area from -2 to 1. Now algebraically, what that means is that you find the antiderivative and you plug in 1 and -2 and you subtract. So if I plug in 1, I get 4 and 1/3. And then I plug in -2, I get -8 and then 8/3. You can leave it like that, or if you work it out, you get 9. Alright, on B. I'm going to graph x plus 2. If I plug in -2, I get 0. If I plug in 1, I get 3. So this particular problem is asking me to find the area of that little triangle. I'm going to leave this for you to work out algebraically. Find the antiderivative, plug in the -2 and 1, and solve. Alright, C. It says for you to find this integral. And notice that they're both, you just take what we got in A, take what you get in B, and then that would be the answer. Now then it says draw a graph. Well, I'm going to put both of these two pictures on the same graph, and you'll notice that they both intersect at -2, 0 and 1, 3. This particular equation, and also this equation, is asking us to find the area between the two curves. You'll notice that the equation in D is the integral of the top function minus the bottom function. And what I'm trying to show you in C and D is that you're going to get the same answer. Okay? So whatever you get in C, what I want you to do is to work out D algebraically, where you find the antiderivative and plug in the values and solve. And you're supposed to get the same answer here that you got in C. So those two answers should be the same if you work it out. Basically what I'm trying to tell you is if you want to find the integral between two curves, you take the top and you take the bottom, you subtract them and do the integral from where they intersect. We're going to skip on down to 6C. If you want to go back and do an AB, that's fine, but you do not have to. 6C said shade the region between those two curves. So, and it doesn't say without a calculator, so I'm going to use the calculator. 3x squared minus 3 is a parabola. It looks like this. 3x plus 3 is a line. And it wants me to find the area between those two curves. So based on what we have already figured out on some of the other problems, if I want to find the area between those two curves, I'm going to take the top one and the bottom one and subtract. So I need to do the integral of the line and then I want to subtract the curve. Now, the place that I stop and start, I find the left point and I find the right point, and that would be the places on the integral, the a and the b. Okay, if I find the intersection, that one intersects at -1. If I find the intersection of the other one, that intersects at 2, so that's -1 to 2. Put that in the calculator, solve, and I think you get 13.5. Alright, we're going to skip on down to 7C. What I want us to do is to shade. I'm sorry it's so weird and that there's an extra little part there, but that's okay. We're going to graph x minus 4. We're going to graph x squared minus 4x. Alright, x minus 4 is the line. X squared minus 4x is a parabola, kind of like that. The part that it would be wanting me to find the area of is the area between those two curves. I would need to find these two intersection points. If you do that on the calculator using second calc and intersect, you'll find out that that one is 1 and that one is 4. So if I want to find that integral, I'm going to take the integral from 1 to 4 of the top function. And then the bottom. If you put that in the calculator correctly, you get 4.5. When I say put it in the calculator, you can just put it in Math 9, and you can put it in that way. Trying to do this in the graph screen is going to be kind of hard. I would just suggest using Math 9 and then putting it in the calculator that way. It doesn't matter whether the figure you're looking at, like in 5D, is above the x-axis, or in 6C how part of it's above and part of it's below, or in 7C how all of it is below the x-axis. You still always just take the top function minus the bottom function and subtract and finding the integral. So your formula in 8 would be the left intersection point, the right intersection point as far as the x values, and then f of x minus g of x, because f of x is the top and g of x is the bottom. Alright, number 9 is your last try problem. So you're going to graph it, and you're going to find the intersection between those two curves. There's one last kind of problem I want to show you, and on this particular problem, it's kind of the top and the bottom thing doesn't work. Let me show you why. Let's say that we had x equals 3 minus y squared, and x equals y plus 1. And it wants us to find out where those things intersect, and it wants us to find the area between those two curves. Alright, first of all, I would have to solve for y so that I could figure out how to graph it. If I solve for y, I would get y equals x minus 1 there. Here I would get y equals plus or minus the square root of negative x plus 3. Now, when I graph this, I would graph x minus 1. And then in the calculator, I'm going to have to put, like in y2, square root of negative x plus 3, and then in y3, I would have to put negative square root of negative x plus 3. Now, after I graph that in the calculator, it's going to look something like this. The top part is going to be the positive square root The bottom part is the negative square root, and then obviously the red part is the line. Now, go ahead and find the intersections. This one intersects at 2, 1. This one intersects at -1, -2. The hard part here, see, I'm trying to find this area, is that on this particular function, and this is the only case that's different from all the others that we've just talked about, there's not a top function and a bottom function, because this would be top for part of the time, but then after the 2, 1 where they intersect, this would be top, and then the bottom changes. You actually can do top and bottom if you kind of separate, but I think it's easier, because there's some problems where you can't do that, to think of it a little differently. And this is the only case, but you're going to do what's called right minus left. You take the function that is farthest right, which in this case is the one where it had the y squared, and you take the function on the farthest left. The left would be this one over here, which is the line, and you do the integral of that. So if you do right minus left, the difference is that you put x values on the integral, the y values on the integral sign. So we're going to put 1 and -2 as the values. So -2 to 1. And then if I put those y values there in the graph, in the integral sign, I have to also put y values there. And so my y values that I'm going to put are y plus 1 and 3y minus y squared. So the right one is the 3 minus y squared. The left one is y plus 1. It'll be in terms of dy now. In your calculator, you can put y's when you go to Math 9, or you can put x's. It doesn't matter after you have it set up. It's that those values are just the variables. Try it in your calculator just to make sure, but you still should get 9/2 either way, however you put it in the calculator. This is the only case where you do right and left instead of top and bottom, and the only difference is that you use y values here and y's in the equation. We're going to do more with this on Monday, but I wanted you to have that idea written already.